Question B. The total distance traveled by P from 0 to K is equal to 57. Total distance mean area under the graph. So this whole thing will be 57. Now, given that T is equal to 3, so when T is equal to 3, the distance and displacement are equal. We need to find the value of K. K is over here. We will only be looking at this part right here where T is equal to 3. This is where the distance is equal to the displacement. Bring every information that I have from the previous question. 57 is from 0 to K, 57 meter. We're not going to use this because this only apply after 3. So let's erase that. We will only be using this part right here. When T is equal to 3, that is when the distance is equal to the displacement. The distance is from 0 to K, that is the whole thing. We want to find this part right here. So the displacement at SK, we need to minus S at 3. The same, so total distance, which is 57, we need to minus the displacement at 3 because 57 is the whole thing from 0 to K. Minus 30. This part right here is SK. We substitute K in here. 12K minus 1 over 3. K square minus 3. And S3 is just 30. 12. 3 minus 1 over 3. 3 square minus 3. This is equal to 30. Now here is 30. So 30 and 30 will be cancelled out. And we are left with 57 equal to, let's bring 57 over here. So negative 3 minus 57, that is going to be negative 60. Let's solve this quadratic equation. First, let's rearrange it based on the power, the higher power first. K square plus 12K minus 60 equal to 0. It's going to be easier for us if it's positive. Change everything to positive. It's easier also for me to factorize if there's no 3 at the bottom. So I'm going to times all this with 3. K square minus 36K plus 180. Let's factorize this. 180 is 30 times 6. That is going to be equal to 180. K 30 times 6. That is going to be 180. And minus 30 and minus 6, that is going to be negative 36. So our factor would be K minus 30 and K minus 6, which is equal to 0. So let's solve for K. K minus 30 equal to 0. So my first K is 30 and K minus 6 equal to 0. My first K will be 6. Now, there's a condition over here that the velocity is positive and the acceleration is negative. V must be bigger than 0. So when K is equal to 30, our V will be 12 minus 2 over 3, 30. This one will give us V equal to negative 8. So we know this doesn't follow the condition of V must be bigger than 0. Now let's test for when K is equal to 6. So V equal to 12 minus 2 over 3 times 6. V is equal to 8. And this is within our condition where V must be bigger than 0. Final answer that is accepted, that would be K is equal to 6. Let's check with the marking scheme. This is 6-mark question. The first question is when we understand when T is equal to 3, the displacement is equal to 30. So this is over here. That is 1 mark. And you have two choice over here. Either you use the trapezium formula, make it equal to 57. I'm using the second method, which is this one, this part right here. Okay. And when you arrive to your answer where K is equal to 30 or 6. Here, the last answer, k is equal to 6, which is over here, is when we test that our v value cannot be negative. K is equal to 30, our value is negative, so we will reject this answer. And that's it. Another method that you can do is when you relate distance is equal to area. So we have a graph that looks like this. This is where it's at 3. This is where it's at k. So when it says that the total area from 0 to k is equal to 57, what does it mean is that all this part right here is equal to 57. Now, since we want to find only k, we need to do this separately. We have part A and part B, area A plus area B, that is 57. Now, for area A, when S is at 3. So from the previous question, S at 3 is equal to 30. My A is 30. Plus B, this is where the trapezium part. Formula for a trapezium is 1 over 2 times A plus B times the height. Now, our A would be this one, our B would be this one, and this is our height. So this is A, this is B, this is height. Zoom out, our base would be this one. So K minus 3, when time is equal to 3, then my V, 12 minus 2 over 3, T, my T is 3, then it's going to be 12, 2 over 3, T, which is 3, this one is cancelled out, so this one will be 10. Here, the height will be 10. At T3, the height will be 10. Now let's put when it's at K. If it's V at K, our 12 minus 2 over 3K. So that is just our height. So this is going to be our A. And this part right here will be our B. And this part right here will be our H. Now, after we have all that, let's substitute that 1 over 2 A 10 plus B times the height. That is equal to 57. Now, let's simplify this. We take away this first. 57 minus 30, 27. Simplify the inside part. 10 and 12 is 22. Is 2 over 3k. 1 over 2 times k minus 3. Let's move 1 over 2 first over here. 54. This one, let's open the bracket. 22 times k, and that is 22k. 22 times negative 3, negative 66. Negative 2 over 3k times k, negative 2 over 3, k square. Negative 2 over 3k times negative 3. So negative and negative meets, it's going to be positive. And then 3 will be cancelled. What's left is just positive 2k equal to 54. Let's solve the same term. And 2 minus 66 and 54. If we bring 54 to this side, so it's going to be negative 66 minus 54. Minus 1 to 0. Doesn't have a pair, so we're going to keep it like that. Equal to 0. Since this is non-calculator paper, let's try and make this 1. So how to do that? We will times 3 divided by 2 to cancel this out. So if we do that, we're going to end up with, it's easy if this is positive. So let's change that. Times everything with negative. So k square minus 36k plus 180, which is equal to 0. We'll follow the same procedure. When k minus 30 equal to 0, k is 30. And when k minus 6 is equal to 0, substitute value of k, and k is equal to 6, v we will have. If we look in the marking scheme, this line is when they use trapezium method, the area method. This one is just purely algebra. If your current strength is integration, then what we can do is, let's use this information. Total distance traveled from 0 to k is 57. How to write that in integration is that integration from 0 to k, velocity, that will be equal to 57. And from the previous question, we know we have two parts of the equation right here. We need to split this from 0 to 3 plus 3 to k. That is going to be equal to 57. So let's split the first part from 0 to k using the velocity function plus the second part, 3 to k, the velocity function, that is equal to 57. Now, integration rule is that if it's a constant, you just add the unknown. Here unknown is t plus, this is power 1. Integration is we add and then divide over 2. So 12 and 2 is just 6. Minus, this one is plus 1 over 2 plus 1, which is 3. 3 and 3 will be cancelled. T power 3 with the limit from 0 to 3. Plus, the second part over here, constant, we just add t. 12t minus, this one is 1. 1 plus 1, that is 2 over 2. 2 and 2 can be cancelled. So what's left is just 1 over 3 t power 2 from the limit of 3 to k. That is equal to 57. Let's put the limit here. 3 plus 6, 3 power 2 minus 3 power 3. Minus when it's 0, we know if this is 0, 0, 0, it's just going to end up with 0. So let's not write that. 3 plus 54 minus 27. Now let's do the second part. Plus, substitute k in t, 12k minus k square. Minus when t equal to 3. 12, 3 minus 1 over 3, 3 power 2 equal to 57. Let's simplify this. 36 minus 3 equal to 57. 12k minus 1 over 3k. This one is 33. 30 and 33 can be simplified. That is negative 3. And we bring 57 here, negative 60. Equal to 0. Change this based on its power. Negative 1 over 3k square plus 12k minus 60 equal to 0. K minus the t and k minus 6 equal to 0. Our v must be positive. K minus 30 equal to 0. So our first k is 30. And when k minus 6 equal to 0, our k is 6. Then it's going to be 12 minus 2 over 3 times 30. That will give us negative 8. It doesn't fulfill our condition. And if v is equal to 6, so 12 minus 2 over 3 times 6, this one will give us 12 minus 4, which is 8. So this is our